All right, today's problem is largest permutation. This problem is on InterviewBit, so you can pause the video, go over to InterviewBit, try the problem, come back, and we'll walk through the solution. Difficulty easy. We've talked about this before, but all easy problems, of course, are not created equal. This is on the harder side of easy to me. In fact, I might even be inclined to say it's a medium difficulty problem. Problem description. Given an integer array, A, actually we get a list here in the Java template of size n consisting of unique integers from 1 to n. You can swap any two integers at most b times. All right, well, that's a little bit unusual in that you have an array of size n and it consists of the integers from 1 to n. So keep that in mind. Return the largest lexicographical value array that can be created by executing at most b swaps. So the question is, what is a lexicographical value array? I'll give you a really simple example. Let's say we had two arrays. Each one has two elements. So array A, first element is 99, second element is 100. And array B, the first element is 100 and the second element is 99. So which one is lexicographically largest? And the answer is B, the one with 100 in the first element and then 99. So it has nothing to do with concatenating integers. If you concatenated everything, 10099 is less than 99100, but the best case for a largest lexicographical value array is that the largest number in the array is the first element, and the second largest element in the array is the second element, okay, and so on. So the combination of these two things, the fact that we have unique integers from 1 to n, and we want to be able to find, well, actually, let me back up a second. So the best thing we can do as far as solving this is for the number of swaps that we're allowed, the first swap, we're going to find the biggest number in the array and swap it to the front. The second swap, we're going to find the second largest element in the array and swap it to the front. So a couple of things might occur to you at this point. One is, swapping, the largest element to the front on each pass, it sounds like a selection sort. We could just do a selection sort, but stop after b iterations, okay? Which would work, but the number of elements in the array could be up to 100,000. Number of swaps allowed could be up to 1 billion. That's pretty big. I mean, you really would not even need more than 100,000 swaps to put the thing in order. But a selection sort is an n squared algorithm. So 100,000 times 100,000 is 1 billion. If we could do better than that, if we could have, an O of n algorithm, just one pass through, 100,000 better than 100,000 operations is better than 1 billion. Okay? So we want to be able to do fast lookups of the largest number and where it's located. And so a hash map comes to mind here as probably the best choice for this problem. All right, input format, yes, we have that. Output format, return an integer array or list. Okay. Yeah, we can return it. I mean, we can update the input list in place. I don't think it really gives us anything to return it, but they are asking us to return it. So okay. Example input 1, 2, 3, 4. We want the lexicographically greatest. Now we only get one swap here. So what we would want to do is find the largest number, which is the 4, and swap it to the front. So the 4 goes to the front, the 1 goes to the back, and then what we have is 4, 2, 3, 1. That's the answer for that one. Now this one is already in lexicographical order, so you know, there's nothing that we need to do with it. Okay, so let's take a look, and we're going to use this. We're going to use example 1. Let me scoot this over a little bit. Maybe I can just pull it like this. Is everything visible there? Yes. Okay. First thing that we're going to do here, this part of the code, is we're going to map the integers in the array to their indices. Okay, that's what line 7 does. So let me get a pen here. I'm going to slide this up a little bit so we can see the important part of the code. But yeah, okay, that's good. Get a pen. We'll draw the map. All right, so the map, the keys are the numbers in the array. Values are the indices. So we have value 1 at index 0. We have value 2 at index 1. Value 3 at index 2. And value 4 at index 3. All right, down here, I'm going to write the, that's not right. I'm going to write the array 1, 2, 3, 4. Okay, so let's go through this. J equals n. Now, n is the size of the list, so let's say J is 4. We'll go through here. Initial index equals map get J. We're getting 4 because the list size is 4, and we are told that the numbers in the list are from 1 to n. N is 4. We're getting the index of the largest number in the list, and that is 3. We can get that from the map. The best index, that is where this number is supposed to be, would be n, 4 minus j, 4, which is 0. It should be right at the front. All right, if initial index does not equal best index, which it doesn't, map, put j, which is 4, with the best index. All right, so for 4, we need to change the index. 4 is now at index 0. We're swapping the elements here, basically, in both the map and the array. Okay, int element equals a dot get best index 0. So what is that? That is a 1. So I'll put that there. Element is 1. In the map, put the element 1 at the initial index, which is 3. All right. That's gone. And 1 becomes 3. All right. In the array, set best index, which is 0, to a dot get initial index. That is, we're getting the element at index 3, which is a 4. All right. So we're going to set 0 to 4. Now, usually when we swap elements, there's a temp element, but this element here actually serves as the temp element. I should underline it here, element. Because we're already using it to do the swap in the map, so we already have it. That's the temp. And then the initial index will be set to the temp. So we set temp to initial index in line 19, set best index to initial index in line 21, and then 21 set initial index to the temp element. All right. Set initial index to initial index is 3, and the temp and the element is 1. So we set that to 1. Okay. One. And we decrement B. Now B was 1 to begin with. So we are done. This is the answer, 4, 2, 3, 1. But I want to go through it one more time, just to clarify how this would work with the rest of the list. So B. Okay, so we'll go back up here. Initial index equals map get J. Sorry, we got to go back to the top of the loop. So this is a 3 now. Map get J. All right, J is 3 and get is 2, so this becomes 2. Best index is N, which is 4, minus J, which is 3, so this is now 1. So we're putting the second largest element in at index 1, the second position in the array. If initial index equals not equal to best index, which it's not, map put J, and J is 3. Put for 3, we're going to put best index, which is 1. Okay? So the best place that 3 could be is at index 1. Int element is a get best index 1. All right, so at index 1, we have a 2. Map put for 2, we're going to put the initial index, which is 2. So 2 becomes 2. Okay, A set best index. Best index is 1. So at index 1, we're going to set, see, get initial index, which is 2, so that would be a 3. So index 1 becomes 3. And then we'll set the initial index, which is 2, to element, which is 2. Okay, erase that. Oh, come on. And that is, no, wrong pen. That is 2. Okay, so now the whole thing is that's the best we can do lexicographically. So yeah, that's how it works with a hash map. Put everything in a hash map. We can do fast lookups, and we run a loop from in a descending order, and in that way we're able to take the largest element, the largest remaining element, and put it in the, well, let me start over on that. We can start by taking the largest element, putting it at the front of the list, and we take the second largest element, put it as the second element in the list, and so on. So 4, 3, 2, 1. Actually, the answer for b equals 1 is 4, 2, 3, 1. Let's double check that. Okay, erase this. Over here, example output, yeah, 4, 2, 3, 1. But that's how it works with a hash map. Let's actually let me do a quick sanity check on this. Okay, and then submit. Okay, thanks for watching. If you found this helpful, hit like, subscribe, check out the playlist on the screen to keep improving your interview skills. If the problem felt familiar, that is because it follows a pattern, in this case, hash maps. I've put together a free guide covering the patterns that show up most often in interviews. There is a link to that, free download. You can get it immediately. There's a link to that in the video description, and we'll see you next time.